Earth's oxygen has an expiration date. What if Earth's breathable atmosphere, the very thing keeping us alive, isn't permanent? Not because of pollution or war, but because of something far older and more powerful, the sun itself. Scientists now say we've passed the halfway mark in Earth's habitable timeline. In just over 1 billion years, oxygen will vanish from our skies, leaving a world where complex life can no longer survive. This isn't ET science fiction. It's a real forecast based on cutting-edge climate and stellar evolution models. In this video, we'll uncover how this transformation happens, why it's inevitable, and what it means for the future of life itself. The science behind the prediction. In 2021, a pair of scientists, Kazumi Ozaki from Toho University and Christopher Reinhard from Georgia Tech, published a landmark study in Nature Geoscience that turned heads across the scientific world. Using sophisticated climate biogeochemical modeling, they predicted that Earth's oxygen-rich atmosphere will collapse within 1.08 billion years. Their simulation wasn't based on speculative theories, but on well-understood processes tied to the life cycle of the Sun and Earth's biosphere. Their core finding is this: as the Sun gradually brightens, it alters the Earth's climate in profound ways. One of the first casualties will be carbon dioxide. Over time, increased solar radiation accelerates chemical weathering, a process where minerals on land react with CO2 and pull it out of the atmosphere. Eventually, CO2 levels will drop so low that photosynthetic organisms, the oxygen producers, will struggle to survive. With these oxygen-producing organisms, plants, algae and cyanobacteria, on the decline, oxygen production will plummet. Simultaneously, natural processes will continue removing oxygen from the atmosphere. The final result is a cascade. First lower oxygen levels, then a complete reversion to an atmosphere rich in methane, water vapor and sulfur gases, eerily similar to Earth's ancient pre-oxygen state. The models predict this transformation will occur quickly on a geological scale, perhaps over 10,000 years, a blink in Earth's history. For humans, that's an eternity, but in planetary terms, it's a flash. This research redefines how we think about Earth's long-term future. It reveals that even without human interference, the planet's life support system has a natural expiration date, set not by carbon emissions, but by solar physics and Earth's own atmospheric chemistry. It's a startling insight that few saw coming. Solar brightening, a slow death sentence. At the center of this dramatic transformation is the Sun, our source of life, and ultimately the silent architect of Earth's demise as a habitable world. What's crucial to understand is that stars like our Sun evolve over time. As they burn hydrogen in their cores, they gradually increase in brightness and temperature. This process, known as stellar brightening, unfolds over billions of years but has massive consequences. Currently, the Sun increases its output by about 10% every billion years. That might sound small, but the Earth's biosphere operates on a delicate balance. Even modest increases in solar radiation cause global surface temperatures to rise. And as the planet warms, a chain reaction is triggered, one that will reshape the atmosphere completely. Here's how it unfolds. Warmer temperatures accelerate the silicate weathering cycle, a geological process where rainwater reacts with rocks, locking away CO2. This lowers atmospheric carbon dioxide levels, eventually dropping below the threshold needed to sustain C3 and C4 photosynthesis, the biological processes used by most plants to produce energy and oxygen. When that happens, large-scale plant die-offs begin. Without plants and microbes converting sunlight into oxygen, the atmosphere becomes oxygen-starved. Meanwhile, oxygen already present in the air continues to react with volcanic gases and is gradually stripped away through surface oxidation and escape into space. Eventually, Earth's skies will resemble those from 2.5 billion years ago, before the Great Oxidation Event. The planet will be dominated by methane, water vapor, and sulfur dioxide, a toxic blend for any complex organisms. The transition will mark the end of an oxygenated era that allowed animals, humans, and vast ecosystems to flourish. And it's all thanks to the sun, doing what stars naturally do, grow brighter with age. It's poetic in a way. The force that gave us life will also gently take it away. What it means for humanity. So what do we do with this knowledge? That Earth's breathable atmosphere will eventually vanish, and there's nothing we can do to stop it. For humanity, this prediction doesn't spell doom tomorrow, but it does reframe how we think about the future of civilization, life, and planetary stewardship. First, it teaches us humility. We often act as if we own the Earth, as if it will always be here for us. But this study reminds us that Earth is part of a larger cosmic timeline, dictated by forces far beyond our control. Knowing our home planet has a lifespan, even if it's a billion years away, should spark a new kind of urgency, not for panic, but for long-term planning. Thinkers like Elon Musk have championed space colonization as a survival strategy. While such ideas often sound like science fiction, the concept gains real scientific grounding when framed against data like this. If Earth has a clock ticking down, then investing in space habitats, Mars settlements, or off-world biospheres isn't just futuristic optimism, it's strategic foresight. This also impacts how we search for life beyond Earth. Many exoplanet studies prioritize oxygen as a biosignature. But if oxygen only exists during a narrow window in a planet's evolution, we might be missing life on worlds that are pre- or post-oxygen. That means our search criteria could need updating, making this study relevant not just for Earth's future, but for how we study other worlds. Ultimately, there is something deeply human about this discovery. We're alive in the middle of a rare golden chapter in Earth's history. The sky is blue, oxygen is abundant, and life thrives. But that won't always be the case. Recognizing the fleeting nature of this moment makes it more meaningful and pushes us to make the most of the time we do have. Recognizing the fleeting nature of this moment makes it more meaningful and pushes us to make the most of the time we do have. Recognizing the fleeting nature of this moment makes it more meaningful and pushes us to make the most of the time we do have.